So in this video, we'll be going over strategic form games. So we'll be covering topics like prisoner's dilemma and Nash equilibrium in this video. So firstly, we'll be discussing the anatomy of interaction. First is the non-cooperative game. That is the concept we'll be discussing. So here the objective is for the person to maximize their own payoff, right? So this has individual primitives. The players act independently based on solely self-interest, right? And there are no binding contracts. And the second thing we'll be discussing is strategy profile, where we will be focusing on the outcome. That is, the player would be caring about the result of the collective profile as a whole, right? As a community, not just their own isolated move. So that is a strategy profile. This is the difference between non-cooperative game and a strategy profile. Non-cooperative game is solely for self-interest and it is subjective, while strategy profile is looking at the whole, uh, the global outcome, right? The outcome of the whole group or the community. Now the rational player, assumptions and intelligence. So we have preferences and utilities. Outcomes are mapped to real numbers. Goal is to maximize the expected utility, E of U. And the rationality is that players have infinite computational power to calculate the best response. Right. Now mathematical formulation, this is a very important part which I'll be discussing here. So basically, just a second. So the set of players is denoted by the set n, and it has players from numbered from 1 till n, small n. And then we have the strategy set for player, right? For player I, it is SI, and also we have UI, which is the utility function of the payoff, and we denote it by this tau, right? And so UI is basically the set S, which has rational numbers, all rational numbers, and UI S of I, S of minus I. What does this denote? That is, SI is basically my choice, and S minus I is everyone else's choice, right? So that is how we denote denote it mathematically. Now the engine of decision, that is best response. So rational players' goal is to choose a strategy that counters the opponent's strategy most effectively. So given a strategy profile S of minus I, what others are doing, a strategy SI is the best response if UI SI comma S minus I is greater than equal to UI S dash I S minus I. For all other possible strategies, S dash I, right? So this is the best response that can be chosen by us, right? This is the best response graphically as well. So the utility is maximized at this function, right? At the function S star I, right? So that is my strategy. Now, case study, the prisoner's dilemma. So we'll be discussing this. So the interrogator's deal. All right. So you don't have to go through this. This is wrongly printed out. So we basically have two prisoners in separate cells, and they have basically committed a crime, and they were a team initially, but now they've been placed in two other cells, and they are being interrogated individually and separately. So they both have two options, whether they can either they can confess or they can choose the option not confess. So confess is denoted by C and not confess is denoted by NC. If neither of these two prisoners confess, then they will serve 2 years in jail. If both of them confess, then they will serve 5 years of jail time each. And if only one confesses and the other does not, they get 1 year. The person who has confessed gets 1 year, and after that he'll be free. And the partner will get 10 years. The person who has not confessed, right? So these are the rules of the prisoner's dilemma. Now this is basically the payoff matrix that has been made here, right? So you can see there are two rows and two columns. This is player one, that is the prisoner one, and this is player two, the prisoner two. And we basically have two columns if player 2 does not confess and if player 2 confesses, and also two rows, uh, player 1 confesses, not confesses, and player 1 confesses, right? So this is how we're denoting it. The blue marked one is basically the time or the jail time that he has to serve in the conditions, and the red one is for the prisoner 2, right? So if both of the players do not confess, that is, none of these players confess, none of these prisoners confess their you know the crime they've committed, then they will both serve 2 years, right? Now, in the case of both of them confessing, they will both serve 5 years of jail time, as it is mentioned in the rules, right? Now, in case player 2 confesses and the player 1 does not confess, then player 1 will have to serve a jail time of 10 years. That is minus 10 in blue. And in minus 1, that is for player 2, that is prisoner 2, will serve 1 year jail time, as was mentioned here. And vice versa, if player 1 confesses, then he is serving only 1 year jail time. And if player 2 does not confess while player 1 confesses, then player 2 will have to serve jail time of 10 years. So this is the payoff matrix, right? Now the trap of rationality here. So solving via best response. Okay, so again, do not consider this is just wrong text here. So rationality leads to a suboptimal outcome individual best responses lead to 5 years of prison time for both, even though cooperation, that is confessing, both of them confess, not confessing, is mutually better, right? So this is a suboptimal outcome. So let us see what exactly this payoff matrix is trying to tell us. So this is better for, what is better for the prisoner one. Suppose let us consider we are prisoner one. Okay, we are player one. So what would be better for us? That is, in case I move from not confessing to confessing. If in case I confess, then instead of getting and also considering the fact that prisoner 2 has not confessed, so in case I move from not confessed to confessed, then that would be better for me, because I will reduce my jail time by 1 year. Initially, it was 2 years if I do not confess, and my partner in crime also does not confess. Then we're both getting 2 years. But when I confess and he's still not confessing, that would be better for me only, right? Then I will get 1 year jail time only. So 1 year sentence, let's 1 year jail sentence is reduced for me. Now, in the case player 2 confesses, and initially I was not confessing, okay, that is, my partner has confessed and I do not know about that, right? I do not know because I'm in a separate jail cell, and both these the deal the deal has been explained to both of us, right? So it is up to my rationality, whether I want to, or it is up to my moral conscience, whether I want to actually confess or not. So now player 2 has confessed and I do not know about that, so I have the option to either confess or not confess. That is in my the ball is in my court, right? So in that case also, if I do not confess, I will be getting 10 years, which is a very high sentence time. And in case I move from not confessing to confessing, in case I do confess, then I get 5 years. So in both the cases, you see that in case prisoner 2, that is my partner, does confess, and even if he does not confess, I will still be getting a comparatively lesser jail time as compared to the one that I would have been getting in case I had not confessed, right? So that is one part I've covered, and that is the same applied to player 2. Keep yourself in prisoner two's shoes, and then also you'll see the same thing. That is, in case I move from not confessing to confessing, and my partner does not confess, I get a jail time from I reduce my jail time from 2 to 1. And similarly, if player 1 has confessed, I move from 10 years to 5. Right, so the same thing applies here. So this is symmetric versus asymmetric competition here. The company's dilemma. This is another example. So symmetric game, symmetric payoffs leading to stable B comma B. Right, this is stable. So you can see here this is symmetric, and you also have non-symmetric game where company 1 dominates product A, company 2 must differentiate. Right, this is asymmetric. We'll cover this company's dilemma topic later. Right now, I will be explaining only this business dilemma. Right. So basically, scaling up the tragedy of the commons. This is again another topic which I'll be discussing here only. A classic case of individual rationality leading to collective ruin. Right. So the math is here. U I S I S minus I is S I minus 5 times the collective of each of the uh, people here upon n. So SI is 1, keep the sheep. SI is 1, keep sheep. SI is 0, don't keep the sheep. Total damage is 5 units shared by n farmers. Okay, I will explain this one also in another video. So let's move on, right? And we have sealed bid auctions, which I'll be covering in the next few videos. Okay,